Chapter 9 review. Going to be pretty quick, I think. We'll see. Make a scatter plot of the data. I take that back. Make a scatter plot of the data. Identify any outliers, gaps, or clusters. All right, so what we haven't had to do a lot is actually make scatter plots. You won't have to do that on the test. Well, I don't think you'll have to do that for the test, at least not for the virtual test, which is why I'm making this video. But this is what it looks like. You have your y-axis, you have your x-axis. This is my x-axis always, and that's my y-axis always. It says here that my age is the x-axis, so I'll put my age, and it's going to be in years. And over here, my height. Let's see what my smallest age is. 3 is my smallest age. What's my biggest age? 15. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I can do that. What I don't want to do is go 1, 2, 3, 4. So what I'm going to do here is go by fives. So I'll go 5, 10, 15, 20, 25. And looking at this, I'm not going to have room to do all that either. So I'm erasing it. I'm going to make them 10s. 10, 15. 10, 20, 30, 40, 50, 60, 70. Do I have to go higher than that? Nope. 70s is as tall as I need to get. And let's make some dots. 15 years, 67 inches. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 67 inches is going to be right below 70. Is this going to be perfect? No, not even close. 3, 1, 2, 3, 38 is going to be probably around there. 14, 65, right around there. 12, 70. Ooh, that's a tall bowl. That's a tall bowl. 8, 1, 2, 3, 4, 5, 6, 7, 8 is 50. So let's put that right around there. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is going to be 58. So let's do that there. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is going to be 53. So let's put that right around there. 4 is 41. Let's put that right around there. 13 is here, and that's 56. So let's put that right around there. And then 10 is going to be 56. Okay. I don't see any clusters. I don't see any outliers. Maybe that's a gap. So I'll put a nice big question mark there. Okay. Okay. For 2, that's an outlier. Remember, an outlier is a point that doesn't fit in. That right there is a cluster. And that right there is a gap. Pretty easy. Your school is ordering custom t-shirts. The scatter plot shows the number of t-shirts ordered and the cost per shirt. Describe the relationship between the number of t-shirts ordered and the cost per shirt. Well, we have ourselves a negative correlation. So I'll say that, but that's a bit lazy. Negative correlation. A correlation or a negative correlation is when your dots go down and to the right. But I want to do better than that. This is a real life problem. So I don't want to just be like negative correlation. It seems that, according to this, the more shirts I order, as the number of t-shirts ordered increases, the cost per t-shirt decreases. So what I will say is the more t-shirts are ordered, the cost per t-shirt decreases. Okay. That makes sense. You've heard of ordering in bulk. But this is definitely a negative correlation. Positive would look like this, and no correlation would be scattered everywhere. Describe a set of real-life data that has each. A positive linear relationship. Okay. So if it's a positive linear relationship, the scatter plot is going to look like this. So, I need two things that increase at the same time. So I like food. Let's do more food eaten and calories. We'll just say food. Okay. So a positive relation is food and calories. The more food I eat, the more calories I eat. That's a positive linear relationship. For a no relationship, that means it could be anything. It could be dots going down and then back up like that. It could just mean dots everywhere like that. It could be straight across. It could be straight up and down. But two things that don't necessarily mean anything is hair color and how smart you are. Hair color and IQ. So I know we're all like, Mr. Perich, I thought blondes aren't that smart. Mr. Perich, I thought blondes aren't that smart. That's a lie. But if you have brown hair, if you're a redhead, if you're a blonde, if you have clear hair like I do, it doesn't matter how smart you are. I mean, I'm the smartest person here, and my hair color is clear. Clear hair color. See, watch me run my fingers through my magical clear hair color. So beautiful. Where's my pick? It's my invisible hair pick. Good job, everybody. This table shows the numbers of hours a waitress works and the amount she earns in tips. How many hours do you expect the waitress to work when she earns $42 in tips? Well, this is what I need to do. I need to come up with an equation. So let's take these numbers and kind of rewrite a few of them into a chart. I don't have to do this. I don't have to do this, but it might help people. Like 2 is an X, and that matches up with 15. And 5.5 is an X, and that matches up with a Y value of 40. Now, what I'm going to do is I'm going to go to my NCTM line of best fit website, and I'm going to do this guy right here. So I have to take my time plugging things into the graph. All right, so I'm going to go to 15. So 2, 15. My next one is 5.5, 40. 5.5, 40. My next one is 1.7. And then you just keep going. 7.50. 2.518. 8.55, 3.20, 5.36. 8.55, 3.20, and that last one was 5.36. That's a 35. All right, I have everything. Our line of best fit is 6.99. You know what I'm going to do? Since a line of best fit, I'm allowed to estimate a little bit. And let's look at the original problem. How many hours do you expect the waitress to work? So it's not perfect. So I'm going to do y equals 7x plus 0.4. Y equals 7x plus 0.4. How many hours do you expect the waitress to work when she earns $42 in tips? So my tips are going to be Y. So what I need to do is I need to replace 42 with Y, or rather replace Y with 42. And it's been a while, but now I need to solve. Minus 0.4 minus 0.4, cross U out. That's going to be 41.6 equals 7x. Divide both sides by 7. Divide both sides by 7. 41.6 divided by 7. 5.94. So I can say about 5.94 is about 6 hours. Now, some of you might be like, okay, so I don't need an exact answer, obviously. What if I just looked at this guy that said $40 in tips and just kind of went up a little bit? So it's 42 is just a little bit more than 40, then my answer is going to be a little bit more than 5.5, and my answer ended up being 6 anyway. Can't I just do that? Yes. I just wanted to remind you how to do the website, though. You can use common sense to do these problems. So the common sense way, again, was if they want to know $42 in tips, I'll just go to the 40 right here, go up a little bit more, and up a little bit more from 5.5 is 6, which is what Mr. Perich got anyway after using that website and taking 5 minutes of our time. It's all good. The table shows the number of students at a middle school over a 10-year period. Make a scatter plot and draw a line of best fit. I'm not going to make a scatter plot. Let's just skip that. I already made my scatter plot for the day. Write an equation of the line of best fit. So let's go back to our website. Let's reset what we did. And I'm going to put these in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the X's are always going to be like right next to each other. 1 is 492, which is the number house I grew up on. So 1 is 492. 2 was 507. 3 was 520. 4 was 535. 5 was 550. 6 was 562. 7 was 577. 8 was 591. 9 was 604. And last but not least, 10 was 618. All right, let's see the line of best fit. 13.98. I'm going to round that up to 14. And again, if you're wondering, why is he allowed to do that? Because all right, no, I'm not going to do that. 13.98x. The equation for line of best fit is 13.98x. 13.98x. What was it? Plus 478.73. Plus 478.73. Sorry for running into you, old table. Yep. Interpret the slope and the y-intercept of the line of best fit. The slope is going to be about, now we're talking about students per year. I shouldn't say 13.98, but I'll say 14. Remember, slope is rate, and rate is given to us as y over x, or y per x. So 14 students per year. And the y-intercept is always what you have at the beginning. So the y-intercept is 470, we'll round it up to 9 students at the beginning. Sorry, Mr. Table again. D is asking us to predict the number of students in year 11. So I can either look at the chart and make an estimate, or I'm going to use the equation that I came up with right here. I'm going to use y equals 13.98 times 11 plus 478.73. What is 13.98 times 11 plus 478.71? Shoot, I think it screwed it up.
That would be 632.49.
No, I got it right. So it gave me 632.49, but I can't have 0.49 students, so I'm just going to say 632 students, which looks about right. The number seems to slowly be moving up, so 11 is just going to be a little bit more than 618. 632 students. Find the equation of the line of best fit for the data in exercise 8. I already did that. That's weird. Oh, the correlation coefficient. What was I supposed to do for 8 that was different? Oh, okay. For 8, it said write an equation of the line of fit. Okay, fine. What I did was I found the line of best fit, which is the same exact thing. And the correlation coefficient was, oh, look at that. 1. So R equals 1, which means, what does that mean? It's a straight line. Remember, the closer your number is to 1, the more straight it gets. So when it is 1, it is a straight line. The table shows the revenue for a company over an 8-year period. Assuming this trend continues, how much revenue will there be in year 9? So once again, we need to go back to our line of best fit website. Hit reset. So you have 120 and 235. Let's type those in. 120, 235. I have 346, 456. I have 568 and 682, 568, 682. I also have 792 and 8108. 792 and 8108. Show line of best fit. 12.15x plus 8.68. 12.15x, y equals 12.15x plus 8.68. Why am I writing this out? How much revenue will there be in year 9? So year is x. I need to rewrite out this equation and plug in 9 for x. Y equals 12.15 times 9 plus 8.68. 12.15 times 9 plus 8.68.
It's 118.03.
Now, the tricky part about this problem is our answer is in millions of dollars. So I have to throw a dollar sign in front of it and say million. Yeah, if a company only made $118 after 9 years, they should probably stop being a company. Ooh, a two-way table. You randomly survey students about participating in the science fair. The two-way table shows the results. How many male students participated in the science fair? All right. Male students, science fair, yes, 32. The answer is 32. Male, yes, is 32. How many female students do not participate in the science fair? 15.
The subscriber you have dialed is not in service. If you feel you've received this message in error, Please hang up and try your call again later. Message NY23956. The subscriber you have dialed is not in service. If you feel you've received this message in error, please hang up and try your call again later. Message OH16356. Subscriber you have dialed is not in service. If you feel you've received this message in error, please hang up and try your call again later. Message NY23856.
I don't know. I didn't call anybody. Is it gone? I didn't call anybody. How did that happen? It still says I'm calling.
Subscriber you have dialed is not in service. If you feel you've received this message in error, please hang up and try your call again later. Message NY23856.
Okay, they didn't answer. I didn't call that person. That was so weird. That was so weird. All right, now. I hope that never happens again because that freaked me out. That's ugh. All right, you randomly survey students in your school about whether they liked a recent school play. The two-way table shows the results. Find and interpret the marginal frequencies. All right, the marginal frequencies are the totals. So I need to add a totals side. And I need to do the same thing for down here. Totals. So the way I get this number right here is I add these two numbers up. 48 plus 56 is 106. No, 104. Adding these two, I get 36. These two numbers are 48 and 12 make 60. 56 and 14 makes 70. And whether I add these two numbers or I add these two numbers, I did something stupid. Watch, look. That's not 36. That's 26. Wah, wah. Wah, 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 wah. All right. So if I added these two numbers, I'd get 130. If I add these two numbers, I get 130. Either way, my grand total is 130. So what this means is, what are we talking about liking? Liking the school play. Over 100 or 140 or 104 students liked the school play. 26 students did not like the school play. I interviewed 70 females. I interviewed 60 males. 48 of the males liked it. 12 of the males did not like it. 56 of the females liked it. 14 of the females did not like it. I asked 130 people total. Boom!